So let's get started. I guess it would be good to emphasize again what are we going to do this week, because it's last week already. So the test will be 3 long questions, no multiple choice, okay, an hour, and we'll cover up to topic 7. So regression is not covered. For hypothesis testing, all the way up to one sample test, when 2 sample tests only required to use Excel. So the complicated formula for the 2 sample tests, you don't need to worry about that. So you need to know how to use Excel for the 2 sample one. But 1 sample one, you should be able to do pencil and paper, okay? And for NOV, as I said, focus on Excel output. I'm not asking you to calculate the SST, SSR, SSW and SSB and SST. Okay, I'm not expecting you to do that, but you should be able to look at the Excel, right? That would be the thing. We'll go for the past paper in the last class. Okay, we'll finish the regression and do some Q&A as well today. So that is what we're doing. I think assignment 5, the solution uploaded already. You can check it out if you have time. And after the exam, we have next Monday and Tuesday, we will do R&R Studio. In case we need something more, then we'll talk over there, but mainly R&R Studio. In case you have already know everything, then you don't have to come. Okay, I would make the 2 days the same. So if you want to come on either day, will be fine. So you don't have to come both. Either day will be the same. So I'll go for R&R Studio. I'll put the slide later on the web, but it will be the B.B.A lab. Okay, it's optional. Also, again, recorded. But so feel free to come, not to come, but because you already have the data cam, so you can, if you can study on yourself by yourself, then don't have to come. Okay, it's more like tutorial style. You go there, I do it with you, and then we learn together. But otherwise, and the test or the final exam is on just 1 hour on Friday, 4:45 to 5:55, an hour only, via ALT5. If you have legitimate reason to be absent, from that you have to get approval from us. Then we are scheduled the makeup for you. Okay, without approval, you'll be considered absence. Okay, unless you have some emergency can prove you're actually emergent, cannot let us know. But if you're unable to do it, you have to let us know. And bring whatever you want to bring. No electronic thing except your calculator. Okay, cannot use your phone to do it. Remember to bring your table. I'm not going to print out any, because you can bring whatever you like. Okay, also bring the student ID, because we check, you need to sign your name there, we check, and that's it. Okay, just make sure that email your TA if you're unable to attend in advance and get approval from us, then we'll schedule the makeup for you. Okay, without approval you can't. Okay, unless you have medical emergency or some other thing that legitimate, otherwise we'll consider you 0 from that one. Okay, any question before we start arrangement? Yes. Free question is here. It's same as the past paper. Past paper are 4 questions. We are free, so you can check the. So you may be like, the question is look like. So look like this past paper, right? Look like maybe 3 part to 4 part, but something like that. Something like it's 1 question like this. But this year, I think I will just make it to 3 questions. The difficulty is similar or easier, I would say. I mean, according to TA, this year is easier than last year. So yeah. Any more question about the arrangement? Make sure you have calculator, you have the tables, and that should be fine. Okay. Yeah, assignment 5, try to do it. There's a solution already, so just at least take a look. Anyway, just so if there are no question, we talk about regression. It'll be very fast because mainly we are going to talk about the Excel output. Okay. At the end, what I want is to tell you how you interpret this particular table, and that's what you need for our class. And mainly this, and then try to give you some idea what are the input there, how to use them. Okay. And that is what you require for you to do the project or in the future. But because many of you actually would do regression in the future, then we'll find this very simple. So nothing deep here. So I try to be quick because it's nothing very deep. Okay, at least our stage. Okay, for our purpose. For our purpose is let's get started. Regression. I'll try to keep it in 1 hour. Okay. Regression mainly is trying to understand how things are related X and Y, and we try to think about their linear relationship. So if you look at this, we are trying to think Y and X are related given by linear function. Okay. The only thing we need to do is to find A and B, the y-intercept and the slope. Remind yourself that what we are thinking is we are trying to explain Y by X. So Y and X have, you cannot really change it, right? We're trying to use X to predict Y or X to explain Y. Okay. And the question we're talking about is like, is higher education lead to higher income, right? Rather than higher income lead to higher education, right? Of course, things can go other way around, but we are trying to use one to explain the other, okay? And that's why last class we talked about is to minimize the distance of the line, the vertical distance, right? It's because X is to explain Y, right? The line is our prediction. It's called the Y hat, right? And the distance is how inaccurate it is, right? If every point fall on the line, then you're perfect fit, right? That's the best, right? And of course, in the real world, it will not be on a straight line because of the fact that there are more something other than X, right? So the distance actually is what? In our theory, is like something we didn't capture in our model, right? So education doesn't lead to income linearly because besides education, whatever income maybe depend on luck, right? Or depend on look, or depend on gender, or depend on parents, right? It's many other things that happen in the world that affecting how much you're making, right? Or depend on the mood of the interviewer, right? Whether you get a job or not, right? So a lot of things affecting things in your life, right? Or it happened to be you didn't sleep very well before you take this class, before the exam, right? Maybe you just 1 mark below the cutoff between A and A minus, make you a cutoff below first on and second on upper, and then make you make a little less money, right? It happens, right? But on average, it's not going to affect, right? On average, the distance is going to be 0. Okay. But anyway, the way to best fit the line is called the least square method. Okay, the least square method basically saying that how do you have the thing, the line will be passing through the center, x bar, y bar, and the slope is given by covariance over variance. Okay, that is the mathematical method to prove it. How to prove it involve calculus, like it's like in the slide 21 up to slide 23, which I'm not going to, but for those who are in QFN, then you can able to go for it, or you're math inclined, you can read that is not complicated. It just involves multivariate calculus. You can do that without difficulties if you learn calculus 1. But that is the formula. Don't worry, you never use this formula anyway, because you just plug in the computer that gives you this number. Okay, so if you have a data, let me do it. So Excel, how do you calculate intercept and slope? These two things, actually Excel can directly output that thing. So let me go to Excel. So that's why I said you don't need to worry too much about that. The Excel calculate everything for you. Suppose I have Y and X. Okay, I have say 1, 1, 2, whatever. I just input some number here. Okay, whatever. Okay, and I want to calculate the slope intercept for the regression. It's very simple. Slope and intercept. Okay, it's just like slope, intercept. First intercept. Okay, and it tells you to input bunch of Y and bunch of X. So very simple. Bunch of Y and bunch of X. Okay, and that's it. Yeah, the intercept give you intercept. Okay, slope by definition just slope. So it's very very trivial thing. Okay. So what does that mean in this scenario here? It just means one thing very simple. It just means Y is equal to negative 0.1 plus 1.3x. Okay? So basically what I do is I have this data. I condense to this formula, right? So now I have a model. We don't need the formula. Sorry. I have the formula, I don't need data, right? I forget about data. The formula, the equation, condense the knowledge I have from the data. With this formula, I'm done, right? So I'm done. This is the same as what you learned recently, a lot of things are called the AI or ChatGPT, right? The ChatGPT basically is just why they can reply so quickly, right? And they are trained based on billions or billions of data, right? Once they train the data, they come up with a model with billion of parameter. Here I don't have 2 parameter, slope intercept, right? But ChatGPT have billion of parameter. But once this parameter, then it's done, right? I don't need to go back to the data. I just use this ChatGPT thing to whatever you tell them, you just reply, right? Based on that thing. Same here, right? Once I have this state equation, I can flow away the data, right? I make a decision. If you ask me, what is my prediction if my X is 2? Okay, I just put in the formula, 2 times 1.3, 2.6. 2.6 plus negative 0.1 is 2.5. My guess 2.5. Okay, you ask me what is X is 0. Okay, not in data, but I will predict it's negative 0.1, right? So even though I don't have data, but this formula will tell us whatever X you give me, I give you a Y. Whatever Y you give me, I can tell you what X, right? So all the knowledge is condensed on this formula. Okay, so that is the power of statistics model, right? Once I make the assumption, I ask the model, the data is gone. This is what I have. I condense all the knowledge there. Okay, so that is a very powerful thing, and actually that's what happened in all kind of stuff, right? Well, how the observatory predict the typhoon, right? The model there, but of course the model come from physics, right? Not from physics and statistics, right? And then tell you, okay, whenever now you see where now the location of the all the input, then come up with output, right? When you have typhoon number 3, number 1, typhoon numbers 8, 9, or 10, so on and so forth, right? So that would be the idea. Okay, and same as all the trading algorithm you see in the hedge fund or investment fund, right? You use the data to train your model, tell you when to buy or sell. Then once with that, then just fit in, and then you can do the trading automatically. Okay, so this is the starting point. of how you learn from the data to the model. Once a model, then you're done. Okay, is that clear? Okay. So for the rest of the class, I just tell you from this, what are the property or how you can use further. Okay, we talk about estimation, right? Because 1.3 and -1 are some estimation, right? Is it unbiased estimate? Disappoint estimate? Do I have confidence interval estimator, right? Should I do hypothesis testing on that? Okay, so these are the things that we will cover next. Don't worry, I just give the formula and you will see from Excel. So you don't need to worry too much about calculation because no one actually do it by hand. I don't see anyone do it by hand. I don't do it by hand. I mean, everyone is by calculator. Okay, so you just need to know the formula and that's it. Okay. Is there any question? If no, then we will go back to the slide. Don't worry, it's not complicated. Okay, just bunch of formula. So as I said, the regression line, you pass through the center of data. Okay, and if zero covariance, the slope will be 0, right? If the covariance is negative, the slope will be negative, as we expect, right? And one thing is, remember, the slope is covariance over variance, right? And I tried to explain why increased variance, the slope will be flatter. Okay, remember the formula here? There's a variance on the below. Okay, let me explain why that's the case. Just one slide. Okay, look at the graph here. Compare red and blue. Okay, red come from red dot, blue come from blue dot. Okay, red is more concentrated at X bar, and blue is less concentrated, right? So that means that the blue have higher variance than the red, right? And when you draw the line, you can see the blue is more flat than the red one, right? So that means that the higher variance, the slope is lower, right? Because the slope is inversely proportional to variance, right? B is equal to covariance over variance, right? Covariance X over variance X, right? So the higher the variance is more spread out, so the slope will be flatter. Is that clear? Okay. And I don't think I need to talk about all this. Okay. This is data. How can you calculate slope intercept? I already tell you how you can do it by Excel, right? But here, just do all the calculation directly. But I guess you don't need to worry about that because I already tell you how to do Excel, right? That's the slope intercept. But if you really want to do it, you can do it by looking at X, subtract from its mean, right? The mean just 3, just add them up, divided by 5 is 3, right? And subtract each one. And you do the same for the Y, right? Y, the mean is 6, subtract each one, okay? And you multiply that, give you the second to last column. You multiply by itself of X to give the last column, right? You add them all up, it's called SXY. You add this all column, is SXX. Slope will be just this over that, 0.7. The intercept will be just passing through the Y bar X bar. So you just put a B here, then you're done. Okay. So you can check it out, but don't worry. I never see anyone doing that in practice. So that's now you know how the formula works. Okay. But no one actually doing that. Okay. I actually asked you to do in the assignment 5, which you don't need to submit. I asked you to do this kind of question, but you can check it out. The assignment, how you can operationalize that. But as I said, everyone just use the formula. Okay. So, okay. So now you can see the least square estimate, minimize the vertical distance, is nothing related to statistics, right? Everything is just minimize distance, give you a point. It's just a math problem, okay? It doesn't talk about anything statistics. So since it was statistics class, we need to come up with anything statistics. Okay. So the problem is rather not difficult. We just say our model is yi equal to some constant alpha equal to some beta plus x plus this epsilon. Why this probability model? Probability model is this guy is a random variable with mean 0 and variance sigma square. Okay, it need not be a bell curve. Okay, in a bell, but in general we will assume there's a bell at the end. But when we do hypothesis testing estimation, we assume this is a bell. Okay, but in general, need not be the bell. Later you will see where we need to assume it's bell, but we just need to say this is the same equal mean equal to 0. The variance sigma square. Okay, and they are covariance 0. Okay, and probably you ask why I give so many crazy definition here. Okay, and these are the assumption that the second is saying the second one saying x are non-random. So x is not random variable. X is chosen by you. Okay, and why we make this assumption here? Because we want to show that the least square coefficient, which we have just done, has nice property. Okay, and in general, when you learn later, we will relax this assumption. But we need to make those assumptions to make it work. Okay, these are classical assumption. Okay, we need to assume x and y are related by this, some constant, but there's some epsilon. So let me draw a diagram here. So what does that mean here? It just means the following. In the real world, you observe x1, y1, x2, y2, so on and so forth, right? You observe this data. Okay. What the assumption means is following. The data you observe can be represented by a scatter plot, right? xi, yi, right? So maybe x1, y1 is somewhere here, right? x2, y2 somewhere there, whatever, there's some point here, right? So the model, what it said is the following. In the world, we actually don't know, but we are saying that yi, okay, is generated by something, some number alpha, some beta, xi. So you give me some level xi, okay? It is generated by, okay, this is alpha, and the slope is beta, okay? Okay? And what you actually observe, y may be here, okay? Y may be here. This is xi, yi, okay? And this height is called epsilon I, okay? So the data you observe is for every x, okay? It actually comes from here, okay? But you don't observe this number directly. What you observe is can be go up and down, maybe here, maybe here, maybe here, maybe here, maybe there, maybe there, maybe here, okay? But on average, it's around here, okay? There's something affecting this guy, but this guy on average is 0, okay? That is what the model is saying, that give me the x, okay? What the y you observe will be on average on the line, right? It can be anything here, anything there, okay? It can be anything here, anything there. Okay? But that is the assumption. Maybe here, maybe here, but can be above or below. But on average is on the line. Okay? Is that clear? So suppose I have x is whatever, maybe education, right? Maybe just primary school. Okay? Maybe 6 years, right? 6 years. Okay? And what's the income they have? Maybe 50K. Okay? I think in Hong Kong, monthly salary, I guess. I don't know. I just make up the number, right? But someone may make more, someone may less. But on average, it's 15K, right? And why different for each one? There may be something we didn't observe, epsilon I, right? maybe how smart he is, and also other thing not captured by education, right? But on average, they cancel out. It go in the middle, right? Say for example, maybe the other x2 is here, right? This may be like the 12 years, right? He finished high school, right? And the average here may be like 20K, right? And it can be somewhere up there, somewhere down there, up there, but on average is here, okay? And the variance of here and the variance are the same. So that is what the classical assumption on regression, okay? Is that clear? It doesn't matter whether this is confusing or not, because you will keep learning that you understand it when you do the proof. But I'm trying to tell you that we have to assume that the underlying is a follow a line, okay? And what you don't observe, okay, affecting the income on average have impact of 0, okay? And this unobserved effect has same regardless of education. Okay? So that's assumption here. And the reason that some of you ask, okay, why we care about this assumption is because when you learn 2021, basically you try to relax assumption one by one. Okay, basically why you spend the whole semester on learning regression is trying to say you relax assumption one by one. Okay, for example, if you try to relax the assumption like last one, okay. So suppose we relax this assumption, observations are related. What we didn't observe is related. It's what we call time series model. It's called like the financial data, right? What you observe today, this minute is related to last minute, right? The stock price have been going up. Last minute, you expect it more likely to go up than go down, right? So errors are not, and what you didn't observe, what you didn't model are related, right? And if you try to relax here and there, you have different type of model, okay? But in our class, we just focus on the simplest one, okay? Doesn't really matter you understand this because it only makes sense if you try to relax them, right? It makes sense to you if you do away with them, what can you do? But I just let you know there's some assumption behind. The first one is just like the underlying is a line, X and Y will be a line. And what you didn't observe, on average, have 0 impact, right? And what you didn't observe doesn't change according to X. Okay. And here is what you didn't observe is unrelated between observations, right? So that basically what it does mean. But anyway, it will be hard for you to understand what it means. Unless you try to relax them, you will know what it means. Okay, we are not doing the proof, so it is very hard to see. Okay, so I don't expect you to know this. Okay, but you need to know under some assumption. Okay, that is what I want to say. What I want to say is under the classical assumption. Okay, what we did in the least square method, right? That's Excel is showing, is unbiased estimator. Okay, so if you really think that the underlying is a line, and you do the least square method, the estimation is great, unbiased. It's efficient as well. It's good, low variance, accurate. Okay, so if you don't want to care about this, okay, which means that's one thing. What we do, minimize recognition, is good. That's it. Okay, if you want to take home message, okay, it means under this assumption they're great, and that's what you need to remember if you really want to do it. And that's it. Yeah. Is that okay? So have a nice property, unbiased. We know what it means. Efficient. We know what it means, right? Lowest variance. Okay. And some interpretation. I think that's most important because we don't care calculation already, right? So we need to tell what they mean, right? When I estimate A is a y-intercept. What's y-intercept here means what will be the average y when x is 0, right? And what B means is, on average, if x go up by 1, on average, y go up by B, okay? These two are the most important thing you learn from the regression, right? Because this is usually what you do, right? Run the regression, and the number will tell us how they're related, okay? And A usually is not very important. The most important is B. B is the key from this model. Key is the essence, okay? Is that okay? Now, we now know A and B are good point estimate, right? We know it, okay? The next part is we want to do point estimate, and we need to do hypothesis testing, right? We want to see actually whether B is equal to 0 or not, right? That is our hypothesis. We want to test, let me repeat, two things. We want to have confidence interval estimate for A and B. We want to do hypothesis testing on A and B as well. Okay? So that are the two things that we want to do. Okay? If B is 0, the model is useless, right? Because X cannot explain anything for the Y, right? If B is 0. We cannot reject the hypothesis that B is 0, right? So that is the main idea. Is that okay? What we're doing for the next 15 minutes or so? Okay. So remember, in this model, okay, alpha and beta are unknown. We just don't know. Okay. And in this model, what are the things we don't know is alpha, beta, and sigma square. Right? In this model, only two things, right? This model feed stuff, slope, intercept, and sigma square, right? And we just know that how to estimate alpha and beta, right? Alpha and beta come from least square estimate, right? And how to estimate sigma? Okay, how to estimate that? Something you would not think difficult, just same as how estimate that, how estimate this guy. So it's very simple. Okay. So you write the equation. Remember the formula is, the equation is like this, right? You just make epsilon the subject, right? You just take away alpha and beta xi, right? And this, right? The variance of this is sigma square, right? So how can we figure out this sigma square? It's very simple. We just calculate the sample of that, right? So what you're going to do is use the data, subtract from your estimated line. This is an EI. Okay. And you just take the sample variance. That will become S squared, and that is estimate of sigma square. Okay. Now, this looks trivial, but let me draw a graph to explain. Okay. That requires some explanation, which is not easy to understand. I'll do slowly here because that's the only thing that I need to explain. Otherwise, other things are pretty straightforward. So X and Y is here. Okay. Remember, our formula said the following. We assume that Y is generated from alpha plus beta X plus epsilon. Okay. This is our model. What it means is, if I have Xi, X1 is here. Okay. According to the rule, it should be here is alpha x1 alpha plus beta x1, right? This is alpha plus beta x1, okay? But you don't observe this guy, okay? You observe something above, okay? Or something below, depend on the realization of epsilon, right? And you have x2, okay? According to the true function, which we don't observe anyway, but maybe somewhere here, but you go up or down a little bit, okay? I don't know which one to realize, okay? And you can observe some data here, there, whatever, right? And once you're done, okay, you can estimate the line, okay? The line need not be the same, right? The line can be something like this. This may be the line based on your data, okay? This line, right? This line is y hat a plus bx, okay? And a and b are random variable, right? A and b depend on what data you actually get, right? What epsilon they realize will affect the a, right? Depending on what data you get, right? And depending on what data you get different line, okay? And you compare this line to it here, okay? This is the residual E1, okay? E1, okay? And this is E2, this is E3, right? You calculate variance of sample variance of E1, E2, and E3, right? All the E's, that will give you S squared, okay? This, the sample variance. Okay. The sample variance of the residual, okay? The line, you fit the line, an actual point you get, okay? This gives you the residual, okay? This gives you S, okay? And don't worry, these are all coming from the calculator directly. The only interesting part is divided by n minus 2. Some of you will question why we have that. The answer is very simple. Because we fix x bar, y bar, we estimate two things, or we fix a and b, we have two parameter fixed. So that's why minus 2 here. Okay. And if you take the square root of that, this is a well-known called standard error estimate. Okay. Or standard error regression. So that is the name it is S. Okay. And for now, we have all the estimates already, right? We have the estimator for alpha, beta, and sigma square, okay? So we got all the point estimate there, right? The model is complete, right? Because we know what's supposed to be line, what's supposed to be, and how the sigma looks like. So we have a complete model description, right? Because, okay, the rest is just, as I said, confidence interval estimate for alpha, beta, and that's it, okay? So don't worry, just a bunch of formula, which you will never look at it anyway, okay? So this estimation will be here, okay? And so this is also, I think, do we have the residual? I think we have. Okay, it's called STEYX, okay? It's the standard error residual. So it's S, okay? How do you calculate? STEXY, okay? Put bunch of Y and bunch of X, okay? So that's N because we have point estimate of the intercept, point estimate slope, and point estimate for the, you do the square with point estimate for sigma square, right? So that is the three things we would like to see, okay? And probably ask why we care about this S, right? because later you will see the larger the S, the less accurate the model is, right? Because epsilon tells us what? This is measure of the estimate for sigma square, right? It's asking how are the things unrelated to the model we didn't capture in the model, right? The larger it is, the worse the model is. But of course, we give a other measure, but this is to note that this is a very important measure as well. Okay. So before the break, I want to show you one equation first. That would be, don't worry, it's very simple. I want to do one thing. Okay. So here is something crazy happen. Okay. A is a random variable, right? So you can actually show that variance of A is based on this crazy formula. Okay. Don't worry, you never calculate that. Okay. So in case you need to calculate, then you can calculate. Okay. And if we assume this normal, A also normal. Okay. Because A intercept. Okay. And standard error like this. Okay. So why I care about that? Because A is normal. Okay. I know how to estimate this guy. Right. I can exactly check A is 0 or not. Right. I have a normal, I test it, that's the hyper testing. Right. I can have confidence interval estimate. Right. So that's why we can do this t-test. Okay. And similarly, I can do interval estimate. Okay. It's just plus minus that guy. And I can also do the same formula here. Okay. I will not bother with the formula, but go to this one. So let me run this directly to here. Okay. Let me run this one directly, show you how to got that, then we should be fine. Sorry, a little bit delayed about the break, but then should be fine. Okay. So I want to show you how to run this. So go to File, More, Option, Add in. Okay. Make sure that 2pack is here. Okay. So what I do is I go to Data Analysis. Okay. I go to Regression. Okay. Now input the Y and X. Very simple. I just tell them Y is here. I tell them X is here. Okay. And I have label. Okay. And that's it. I can just tell them where to output. I just output here. Okay. And then we're done. Very simple. Tell them X and Y. If label, put them label, and that's it. And click OK. Okay. And this is the result. And let me talk about these values before we, and then I talk on over after the break. Okay. But basically, we're almost done. Okay. You can see here, this is same as the result here, right? There's two number. The standard error, as I said, is calculated from the formula here. Very crazy formula, which I don't think anyone would actually do the calculation. This is S of 8 intercept. Okay. This is intercept. Okay. And you do the calculation. Very complicated. S of B. Okay. So that is these two number, standard error of A and B, right? This is A and B, right? And the t-stat is what? You are testing whether this is different from 0. Okay? Like the ANOVA. Here, you can't reject the intercept is 0. Right? Because p-value is a two-tailed test here. The p-value is 0.9. You can't. Right? But for the beta, you can, because only 1%. Right? So if you use 5%, then you would reject. Right? So that means that is not equal to 0. Okay? And you probably also want the confidence interval estimate, which is this. Okay? The point estimate for the intercept is -1. And the interval estimate is -0.7 up to 2.5. Okay? And the slope is 0.5 to 2. Okay? So basically, you understand what the below means, right? So that means that once you see this P is, right? Basically, the most important part is this, regression this guy, right? Bless you. So you see this is 1%, so you're good, because this regression useful. You will keep this, right? Because although it's 1.3, but it's not clear that this is useful thing, right? And usually the minimum requirement, as we do regression, is to require this p-value, right? At least 5% or less, right? And then we start using this regression, right? Otherwise, if not less than 5%, then probably we have doubt on whether this is good or not. Usually, if that's the case, we'll ask you to collect more data before we use it, right? So that's pretty much for regression. After the break, I'll briefly go over what the ANOVA, what it does. Okay, but you will see in this context the same. Okay, the F test actually do the same thing with the T test, so that's why I didn't mention it before the break. After the break, I'll briefly mention about the F and probably ask, since they're the same, why you bother? It would make sense when you go to 2021, because when you have more than x, you have x1, x2, x3, right? In that case, you are seeing whether the whole model is useful or not. This is just for only one coefficient, right? Because of x1, x2, each one will have p-value, okay? Your first thing to do is to check this guy is less than 5% or not, and then you go one by one, okay? But since it's not 2021, so I think up to here, you are already happy, okay? And after the break, we'll mention one more thing. That's the last thing we want to mention is the very first item here, R square, okay? Sorry, this one, R square, okay? This R square, I'll explain what it is after the break. This simply means 0.98 means 89% of the Y explained by X. So this R square is between 0 to 1. The closer to 1, the better the regression is. Okay? I will explain this in more detail after the break, but after that, then and almost everything is done. Okay? Let me have a 15 minutes break. I'll open the U reply. You can ask me any question you want, but you can see the regression is not very complicated, right? So basically just you run this regression, it tells you the model, you do look at the p-value, look at the R square, and that's pretty much of this model you need, okay? Let's do the U reply. In case you want to tell me what you want. So as I said, what I covered today is not within the exam, so you don't need to worry too much about it. But I would you can see it's not very complicated. So I would kind of thinking that you may apply in your project. Okay, and please let me know what you don't know, because I guess we'll finish the regression very quickly, just maybe 10 more minutes. If no question from you, I will start reviewing the whole course. There's nothing to teach, right? Because regression, we're not teaching the formula anyway, right? Just look at the Excel and actually you're done. Nothing to teach. Okay. That's a break of 15 minutes. So let's resume at 3:40. Please ask question in the U reply so that I can help you to clarify. Okay. More than 5%. More than 3.something. More than 15 already. Right hand side still better than previous session. You can try. Right? Always be zero. 3 or 4. Yeah. This is set up already at a very, very high. Yeah. The difference between very high and zero. Because I noticed what is it. Yeah. Right hand side. So you can write the Excel formula, right? Excel formula. The air is not there. They open the door. I guess I should continue and let's see what the question you have right now. So the first question is to clarify p-value of two samples cannot be calculated by hand. Yes. No. In our case, we use by t, right? The t distribution. We can't. Unless you talk about proportion. Proportion you can calculate by hand, right? Because proportion is z, right? So you can still by hand. But as I said, for two samples, I just ask you to do Excel, right? Input, right? So you don't need to worry about manually. And no, because it's continuous function, so you cannot really adding. What it actually is have to integrate, right? The area, but we don't have to do that by hand. No, you can't do it by hand, right? Because adding is wrong because it's a continuous, right? You can't really do that. How to find p-value of f? You can only do Excel, okay? F. And to remind you that for the F or the F table, you only need to do Excel, right? Because I said 2 sample tests, only Excel. ANOVA, only Excel cover, right? So you would not, actually, you would probably do not need the F table, right? For our exam, but yeah, unless I ask you, but otherwise it's not. T-stat, how to find p-value? You can't find p-value for T-stat. No way you can do that. Only Excel. Question 1 asks you to Excel input, okay? I intend to talk about this next class, but Excel input for this one. Okay, we can talk about now here. This sample variance, Excel input is very simple. Just, right? That's the answer. That's the answer for A. That's it. Okay. That's what I mean. I want you to know the Excel input, right? So I need you to know how to do Excel for the summary statistics, right? Descriptive statistics, right? And also 2 sample hypothesis testing, right? And also ANOVA, right? ANOVA, just read the output anyway, right? Okay, I hope I answer your question. Or if not, then just you can ask me again or just leave further reply. Question 3. How you test ANOVA? Excel is Excel output, as I said. ANOVA, as I said, I was expecting, you know how to understand this table, okay? If like the past paper, right? I try to take out some number here, take out some number here, take out some number here, right? And you should be able to tell me, right? Or even I take out this one, right? You can tell me what I'm missing, what is your conclusion, right? So that what I'm asking, right? So that is the question, okay? So you should know what they mean, right? I hope I answered your question. If I didn't, then let me know. P-value, how to find the p-value? Oh, I think we have been doing it's inverse, the p-value, right? Suppose your Z, you calculate like something like 2 here, right? You're doing a test like mu is more than 0, right? Mu is equal to A, and mu bigger than A, right? Then the p-value will be just this area, right? Based on this, right? And your p-value based on Z will be just norm, right? As inverse, p-value based on this, this, right? 2, true, okay? And 1 minus, that's the p-value for the Z, right? You can say this is the 1 tail, right? 2 tail multiplied by 2, right? And so on and so forth. Is that okay? And please go through hypothesizing ANOVA again as revision. Well, that is a huge thing. You have to be more specific because to review that it cannot be done in one class, right? But we maybe more specify what do you want to know. But I will try to do that if no more question about after I talk about regression. But ANOVA single, okay, to keep it short, okay, ANOVA single factor, you should ask yourself, do you able to understand how you get all these numbers? Okay, how you get these numbers? Okay, of course, these I don't expect you to know, right? But if I cross out one, you have to be able to know, right? And how you get this from this, right? How you get this from that, right? And how you get this from this too, right? And how you compare this to get that one, right? How you get this guy, right? How was Excel input to get this guy? P, right? How you get Excel input from this F critical value? Right? You should be able to do that, right? That's what I'm asking. I think I explained very clearly in the class. If you still have questions, we'll go over the sample question, right? Next class. Well, more or less similar to this one. So we'll go over again, don't worry. Okay? Because the sample question asks you this, right? If you look at sample question, 3 is asking this question. So we'll go over next class. So don't worry about that. So that's why I don't want to repeat. Hypothesis testing. Actually, we also go again is the question 2 in the sample question. So we'll do it again. But the question probably I want to give you quickly review is what hypothesis testing is, right? And probably first thing you need to know is you need to know for a case, for one sample, right? We need to know whether you use the Z test or T test, right? If you know the sigma square, Z test. Don't know, T test, okay? And the second thing, look at the question. Is it asking you a one tail or two tail? Once you're done, then you just operate. Don't worry, we'll review the question, then you know, okay? So hopefully kind of answering question, but if you have time, we go over some question, okay? I hope make you feel happier. Okay, everyone knows it's Monday, that's good. The weather, okay, we have consensus today, surprisingly. So regression Excel, it's okay you're listening, but I hope when you have time, you can read the notes or go back and check because regression will be useful for the if you do the 2021, okay? And as I said, regression is the single most useful thing from this class, okay? If you ask me, what is the thing that you will be likely using in the future is regression, okay? And to use it is not very difficult, right? Basically, run the regression, use Excel, look at the p-value, and that's it. So it's something, the easiest thing you can do from this class, right? Of course, it requires a lot of knowledge about why this is good, right? So the speed is okay. I don't want to exam. So already we only have 1 hour, so it's open book. So I think already the minimum thing I can impose, okay? If you want, we can make it half an hour, right? But that will be too crazy. So 1 hour will be already short enough and open book. So already I really do one question, only 3 questions. So I don't know how much I can go down further. Oh, this is fun because should let it go. I like it. This is a good one. This is a good exam period. Yes, the most painful thing, but you notice when you are a student, you still exam is a good thing. When you go to work, every day is exam. Okay, actually, it's much worse. Now we still only care about the last period. Yeah, haircut because you asked me to do the haircut. I just do it on Saturday. So hopefully that make you happier. So let me finish the regression. Then if sometime I'll talk about hypothesis testing because some of you asked me. I just review a little bit about that. So let me quickly finish the regression a little bit because I think that would be almost done. So the regression a little bit here is the R square. There's something I didn't explain. Okay. It's an over part. Okay. Don't worry, it will be one graph, then I'm done. Okay. So just one graph. The graph I'm doing is basically this graph. Okay. This graph will explain the R square thing. Okay. Remember what we have, the data is the green dot. Okay. And I want to draw a line, which is the, I think it's okay now. We're going to draw the line, which is the y hat. Okay. And what actually we're doing here is our model, okay, is this one, right? Our model, if you give me x, our model will give this y hat. Okay. If you don't use the model, what you do? Y bar. Y bar is the thing to predict y if you do the model, right? Let's repeat the first thing. I have scatter plot. If you ask me to predict what is the y, okay? If I don't allow to use any x, what I do? Y bar. Y bar is a prediction without model, right? If I model, this is my prediction, right? Okay. And what I want is actually, I want to explain the blue one, right? Because this is the thing that not explain the y bar. It's called SST, right? The distance. S is a square, okay? I square that part. Is right? And what the model explains is SSR, right? And what is unexplained is SSE, right? R square is defined as SSR over SST, right? If everything fall on the line, this R square is 1, right? So the closer to 1, the better, right? So R square is defined as the percentage of variation of y explained by variation of x. Okay, so that's it. Okay, so closer to 1, the better. Okay, and the formal formula is like this, but I don't think you would care about this formal definition, right? Because already this is there, right? It's already this graph. So I never remember the formula, but I remember the graph is already sufficient, right? Always remember this graph, right? This graph is what is explained, right? It's SSR over what you want to explain, okay? So closer to 1, the better, okay? And some of you see R square, okay? One final comment is how is this related to the coefficient or correlation in topic 1, which is R, okay? And turn out to be topic 1, the R you square is equal to this one, okay? So let me go to Excel final time, okay? We can calculate this, okay? R square, R, okay? R square is equal to RSQ, okay? Bunch of Y and bunch of X, okay? And this R square, okay? And let me do one more thing there, okay? You will see the CORR, correlation coefficient, okay? Y and X, okay? This number, and you take the square. Let me do one more. Okay, you CORR square. Okay, you take this square, is R square. So just final remark, okay? So that you expect, right? Because everything fall on the line is 1, right? Both R and R square is 1. So that's why we call R, right? The same thing. So this is E. So basically, I explain all the regression stuff, okay? And that's what you need, right? Because this is the F test, okay? Okay. So there's not much thing I want to talk about, okay? Basically, run the regression. You can do it in your project, right? You want to explain Y and X. If you have the data like this, then you want to see this is p-value, right? And tell us the coefficient, and that's pretty much the model, right? Remember, this is the beginning point of building a model based on statistics, right? You have a bunch of data is here, right? And you condense your knowledge into this coefficient, right? Once you're done, you want to see whether this model is due to coincidence or has been meaningful. Look at the p-value, right? That's it. That's basically pretty much, right? Once you pass through the test, you can use the model to do whatever you like, okay? I think that's conclude what we want to say, okay? If no question, I will review stuff, but before that, I mean, let me can ask question. No? Any question? If not, then if you don't against it, maybe we can start reviewing the sample paper first. I mean, in case we're done, then you don't need to come on. You don't need to come on Thursday, right? So you in case, but I don't know whether we have time to finish everything. Okay. So question 1A already we see, right? I have sample variance, right? If I ask you population variance, you also know how to do that, right? If population variance will be just VAR dot P, right? Same thing, okay? And then you need to know, for example, if I ask the mean, median, or whatever, range, or coefficient variation, you know how to handle that, right? So this kind of question, you should be able to do that, but as long as you bring your slides, you should be able to, no problem, right? You can just copy and paste. So shouldn't be an issue. So this one, I have a Poisson mean of 90. How to calculate that? Okay, ask Excel only. So let's look at the question. A little bit tricky. Okay, the question is write that down. It's here, right? Here is number of accident. Okay, follow Poisson, right? With lambda, which mean is 90, right? If I correctly. Okay. Yes. So the question is asking, we call the X, right? We are asking probability that X, okay? Here a little bit tricky because discrete, I said more than 92, have to be very careful. Is it mean this guy? Okay, more than, okay? It's not more than or equal to, it's more than. Have to be. And to calculate this, can you add them all up, right? Actually means you have to get 93, 94, 95, 96, 97, 98, 99, 90, blah, 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 up to infinity. So there's no way to do infinity, right? But we know this is actually is come from 0, 1, up to 92, right? And but that is also, we know from Excel, this is X is less than 92, right? Same, right? Right? And this is just F92, right? Just F of 92, right? And that basically just equal to what? Poisson dot this 92 and 90 true. But sorry, I have to take 1 minus of this guy, sorry. Right? 1 minus, 1 minus. So this is the answer. Okay? There any question? I just slow down to ask you the question. The question asked to the right hand side, right? You do difficult to take the left hand side, right? Left hand side actually the Excel function. Is that okay? Okay. The only thing can be tricky is this is 92 or equal to. If equal to, more than equal to, then you have to 91, right? So have to be a little bit tricky. They have to be careful when you have discrete. Have to be very careful about that. Okay. So here we have a question of boys and girls. Okay. Group X have 10 boys, 40 girls. Y have 5 boys, 45. And chosen at random. And there's a girl. It's from X. So that is the question. Okay. So let's draw the thing first. Let's write. Okay. Let's do this. Our group X here. Okay. I have 10 boys, 40 girls. Okay. And I have group Y. I have 5 boys and 45 girls. Wait, that's the question, right? And the question tell me I have half of the chance I'm here, half of the chance I'm there, right? So that's the question. Okay. And the question is, I got a girl, it's from X. So the question is asking probability of a girl given from X. Okay. So let us rewrite the question again. Look at the, is that clear what the question asking? Okay. So this is setup. Make sure that you know the setup. Is there any question about the setup? I just write down the question only. Okay. Is that okay for the question? Is that clear the question what it's asking? Okay. Now, what I want is I would like to write down everything there, right? What does that mean? That 1/2 here. It means that probability of X is 1/2. This is probability Y is 1/2, right? This first thing, right? Random guy, the guy is X or Y is 1/2. Okay. Second thing is I know is the probability that I have a boy in given X is 50 over 10 over 50, right? And probability of a girl given X is 40 over 50. Is that clear for this one, right? If I am drawing from X, right, it would be like this, okay? And if I have girl, if I girl, I'm from Y, boy first, okay? Boy is 5 over 50, right? Girl will be 45 over 50. Okay? So if you don't like this one, let's rejoin like this. 1/2, 1/2, get to X and that to Y, right? And then you have boy and girl, right? Let's go back to here, right? And you have 10 over 50, 40 over 50, right? This is 5 over 50, 45 over 50. Is that clear? Okay. This and it is the same for those who want like a tree. Okay. Is that clear how this question is out, right? Because first you draw which class they're drawing, right? 1/2. And after you draw the class, you draw a guy. Is that clear? Okay. So let's go back to this one. Depending on which one you like, I'll do both in case you would. So this one, okay. How do we do it? We have this guy, right? So obviously, you're swapping base rule, right? Base rule tell us what? Base rule tell us this, right? You have the denominator x, right? And what you do is you swap this guy and multiply by this. Is that clear? Is that clear? This is the base rule. You forget, go back to your slide. This is copy, right? There's nothing new. And check it out. This, we don't know. Okay. This, okay. Sorry. The question is given is a girl, the question is like this, sorry. The question is given as girl is common x, right? So sorry for the mistake here. Okay. The question is asking, given is a girl, right? Like here from x. Okay. Sorry, the question asked this question, right? Given is girl, what is x? So that means that I use the black color. All right. So this is the question. So probability x given g, right, will be probability g given x times probability x. Okay, so that would be the question. Okay, and what we have is this guy, right? This guy's here. We're done, right? And this guy is here, right? This 1/2 is here, and this is 40 over 50. Okay, what is left is this very annoying denominator. Okay, how to get a g? Okay, remember the base rule we do is you use the total probability rule. Okay, how to get the g? G, there are two ways to get a g, right? You get a girl, you get from the x, you get a g. You get the y, you get the g, right? So that's very simple. It just, the formula is, if you look at the formula, is g given x times x plus g given y times y, right? And that's very simple. Why? This is same as the numerator, right? And this is here, and this is here. That's it. I slow down a little bit, but this is the standard way to do it. Is that okay? So just plug in the number, then you're done, right? The only thing you should know is this is the base rule, this is a standard technique, right? So let me talk about this one is also very simple, right? Because the question is, look at the diagram, right? We said, given the girl, right? How likely come from x, right? That means that we know the girl, only this is true. right? So that means that it just this as the numerator, right? Remember, it's just this branch over sum of the two branch, right? It just this is upper branch plus the lower branch. That's done, right? Let me write that down. This is here, right? This is here, and this is roofing here, right? So graphically, it's very simple, right? Because now we no longer need the boys. We know the girl, right? What left is two branches. How likely is from the above, right? Because I now know girl is true. So the tree actually reduced to this one, right? So basically, I just calculate the relative, right? Over the total possibility. That's it. Is that okay? So let's do a variation to make sure that you know, okay? Let's now ask the question. Ask yourself, what is probability of a boy, if I figure out the boy, how conditional boy, how likely is Y? Ask yourself. For this one. How can you figure out this? I give you 1 minute to think about this. I'll tell you the answer now, after 1 minute. Use the graph or use the formula. I'll tell both. Okay. I'll do that. And extend the question, right? If I found out it's a boy, how likely he come from the class Y? If you know how to do it, then you know the base rule. So done. Okay. So it's not very complicated, right? So if you use the graph idea, that is super simple. Why? Because now you know it's B is true, right? So only this and this matter, right? So that is the denominator part, 1/2 plus 10 over 50 plus 1/2 plus 5 over 50, right? Numerator, Y, just this guy, right? And that's it. Okay. If you do the formula, the same, right? You can do the formula, right? Let's do the formula directly. So if I want to do this directly, we will like this. Probability Y given B, okay, will be the probability B at denominator, probability B given Y times probability Y, okay? This guy, 1/4, and this guy, 5 over 50, okay? And how likely you get a boy? Remember how to get that? Boy can be boy from X times X plus boy from Y times probability of Y, right? Do remember that this is 1/2, this is 1/2, and this is 10 over 50. Okay, so that's it. I hope that become clear how you space rule, right? So I guess we still have 2 questions. We'll do it next class, and then we'll do Q&A. Okay, when the lab over. Okay, I will see you on Thursday, okay, and then we have an exam on Friday. So so good luck. I know last week we'll be very busy, very tired. I hope the review is helpful for you to make you feel more comfortable. Okay, I'll see you on Thursday and Friday. Say okay, bye bye for those who in Zoom.